this next unit that we're going to do is kind of a nice break from all the heavy algebra trig stuff we've been doing recently. Yeah, it's all graphing. So it's kind of a nice break. I love trig graphing. I think it's fun. Remember like the wavy graphs? You've seen like graphs look like waves? That's what this is. So where the points for the sine graph and the cosine graph come from are just the unit circle. And so we could sit there and plot every single sine value around the circle, or we could plot every single cosine value around the circle. It'd be really obnoxious, but we could do it. But we're only going to graph the values at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these four. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So at 0, what's your ordered pair at 0? 1, 0. Up at pi over 2, 0, 1. At pi is negative 1, 0. And at 3 pi over 2, it's 0, negative 1. Alright, so when we're looking at, like, just graphing the sine values, oh, what happened to it? Oh, that's weird. Okay, but it does maybe. Okay, leave it there. Alright, so when we want to graph sine, what we're going to do is just take the sine values, or the y values, from all of these ordered pairs. So at 0, your sine value is 0. So that's the first point on the sine graph. The labels on your x-axis are actually going to be your angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. I could have spaced those out. So, okay, so the x-axis is actually going to be labeled with your radian angle measures. So just bear with me for a second. Where did you get 0? So the sine, so these are all of your angles. If we're trying to figure out what the sine of 0 is, just use the unit circle. The sine value at 0 is 0. Likewise, the sine value at pi over 2 is 1. So that would correspond to the ordered pair pi over 2, 1. The y value. The y value, yeah. At pi, what's the sine value? 0. So at pi, we're at 0 again. At 3 pi over 2, the sine value is negative 1. So 3 pi over 2, negative 1. And then last but not least, at 2 pi, back to 0. No, you could have spaced it out if you wanted it to, yeah, make it not so cramped. Those 5 dots are the 5 dots you need to remember for the sine graph. You have 3 in the middle, 1 high, 1 low. So when you graph it, when you go to connect them, it's a wave. Don't connect them with straight lines. Okay, that is what's called one period of the sine function. So this graph is going to this pattern is going to repeat over and over again in both directions. So if you keep going around the unit circle and get to larger and larger angles, those same sine values are just going to repeat over and over again. So from here to here is one period. And then I'll draw the rest of it in a different color. So after you get one cycle, then you just keep that pattern, that wave pattern going. So if you wanted to fill up your whole graph, it would look like that. Okay, so just the same, like, evenly spaced waves. They each have a height of 1. You have an up wave, it hits the x-axis, then you have a down wave, and it just repeats over and over again. You may have done this a little bit in honors algebra too. Yeah. Hold off on that. Once we get to democracy. Alright, so when you look at this, amplitude is basically the height of each individual wave. So amplitude and period are both technically like heights or distances, so they'll both always be positive. Amplitude, if you look, the height of each wave from the center is just 1. And then the period just means how long does it take for a cycle to repeat. So from 0 to 2 pi, you get 1 full sine wave, and then that cycle's going to repeat again. So the period is just 2 pi. So that's your parent sine graph. The things that will change the amplitude, think about if you change the height of a graph, what kind of transformation would that be? Stretch which kind of stretch? Vertical. So vertical stretch, and if you remember, vertical stretches put a number on the outside of an equation. So like a 7 here would make those waves go up and down to 7. 7 and negative 7. What would change a graph? So the period is like this distance, a horizontal distance. What would change, what kind of transformation would change that? Horizontal compression or stretch. Yeah. So, and then those numbers would be like inside the theta. So that's what we're going to focus on today, like graphing the parent function, and then if you have a horizontal or vertical stretch or shrink, what that does. Alright, so that's sine. Okay, so it starts at 0, goes up, middle, down, middle, and it repeats. Cosine, we do the same thing to get the cosine graph as we did the sine graph, except when we do this, cosine, we're looking at the x values, or the x coordinates. So, what's cosine at 0? 1. So I think I lost this. This will just be cosine x. So already it's going to look different. 0, 1. Instead of starting at 0, 0, we're starting at 0, 1. The labels on the x-axis are the same. And just because mine looks really messy with all of them filled in, I'm just going to label pi and 2 pi. With pencil on your paper, you have more space to label pi over 2, pi, 3 pi over 2, and 2 pi if you'd like.
Why are you putting them there?
What do you put in what?
Pi.
Because like the first tick mark would be pi over 2, second tick mark would be pi. I just didn't write all of them in because they look messy. At pi over 2, what's your cosine value at pi over 2? 0. So we did 1, now we're doing 0. So pi over 2, 0. At pi, what's your cosine value? Negative 1. 3 pi over 2, 0. And 2 pi back at 1. Okay, so when you first look, those dots very much look like a V. But both sine and cosine are going to have the same like wave shape. So when you connect it, pi is negative 1, yeah. So kind of what happens with cosine is you have like half of an up wave, a full down wave, and then half of another up wave. And then you're going to fill in, so again, this is 1 period. The period's 2 pi, the height is still 1. But I feel like you don't really see what the full cosine graph looks like unless you fill in some more. So if we keep this pattern going, down, down, up, and back the opposite direction. These dots follow the exact same pattern as sine. They just hit at different times. They have different starting values. Because really, if you were to take the graph of sine and lay it over the top of the graph of cosine, really they're just off by a little bit. If you shifted one of them like left to right, they would look identical. So that's why amplitude, period, all of the stuff that we talk about with sine and cosine is going to be exactly the same. The difference is going to be those 5 dots at the beginning, how you plot them, whether it's sine or cosine. Okay, so when you look at this bottom part, well, this is kind of what that worksheet that I gave to you, for those of you that weren't here on Friday. Amplitude's 1, period's 2 pi. So this is kind of what we were talking about earlier, where like this number in front is your amplitude, and it's your amplitude because it's your vertical stretch or shrink. So that's what's controlling the height of those waves. So it's super easy. If you look at an equation, if there's a number in front of sine or cosine, that's the height of your wave. If there's no number there, then you know it's just the height of 1. Amplitude is the height of each individual wave, not like the whole height of the graph. It would just be like 1 each wave. And then the period is going to start off being 2 pi to begin with, unless there's some horizontal stretch or shrink. And the horizontal stretch or shrink would happen here if there was one. And to figure out what the new period is, we're going to follow that formula. And I'll explain to you how that works here, but basically you should be able to pick out really easily what your amplitude and your period are from your equation. If you can get those set, graphing is not too difficult. This says horizontal. I shorthanded stretch and shrink a lot. I cut out most of the letters, and the letters that I have up there don't even really look like the letters they're supposed to be, so it's fine. Okay. So the next couple examples, these are ones that are like on that worksheet that I gave you, that I want to make sure that like tonight, if you could go back and try some of them if you haven't already. So when you look at this first one, what's our amplitude? What's the number in front of sine? 1. Period? Not quite. So the period, it starts off being 2 pi, unless there's a horizontal stretch or shrink. Is there a horizontal stretch or shrink here? Yes. Okay, so this 2, think back to when we did all the transformation rules. What would that 2 be? A shrink by 2. A horizontal shrink, you can either say by 2 or by a half. So if we started off with 2 pi originally, and we cut it in half, it would just be pi. So you don't have to think through it that way every time. The formula that was on the front of that, where it says, hey, to figure out what the new period is, take 2 pi and divide it by whatever number's in front of x. If you take 2 pi and you divide it by 2, what are you going to get? Just pi. So for the next one, you would take 2 pi and divide it by a third. Amplitude is 3, yep. And then the period, you're going to take 2 pi, divided by a third, which is the same thing as multiplying by 3. 6 pi. Amplitude cannot be negative. So it's an absolute value, yeah. And the reason why amplitude and period are both distances or heights, yes. So the negative, though, what would the negative do if you think back transformation rules? It would flip it. So like normally the sine graph looks like this. If you reflect it over x, it would just go down first instead of going up first. They look like, if you graph sine and cosine at the same time, they look like DNA. Yeah. Alright, so your amplitude would just be 4. Yeah, so to do the period, you'll have to take 2 pi and divide it by 2 over 3. which really makes 2 pi times 3 over 2. And you probably want to put a 1 underneath that 2 pi so you're not tempted to do the 2 on top and bottom. It's just a suggestion. So we'd get 6 pi over 2, or really just 3 pi. Okay, so with the horizontal stretch and shrink, you have to flip it first and then decide. So like this would actually be a horizontal stretch by 3 over 2, which is why that's bigger. And only for the horizontal ones you have to flip it. Last one. Amplitude is 1/2, period.
Oh, no, it would be half
Pi over 2. So you're going to take 2 pi and divide it by the number in front of x. 2 pi over 4 just reduces to pi over 2. So that's how you figure it out by just looking at the equation. I think it's even easier to pick out this stuff if you're looking at the graph. So first of all, let's decide whether this is sine or cosine. So it all depends on your starting point. See how it's starting up at the high point and then goes down? Cosine. I think of cosine as like a jump rope. Like I call the cosine the jump rope graph. If you imagine, like if you stand and you hold a jump rope, it's high on the ends and low in the middle. That's what cosine does. So no, the other one, like when you like if you just look at it like a segment of it, it would. But like if you look at the starting point, the sine wave looks like that to begin with. Versus cosine to begin with, if you just look at that first section of it, looks like a jump rope. Amplitude here, 1. And then period is just how long it takes to make one full cycle. So in this case, we started at the high point, we got back at the high point at pi. Like that? Trying to sort of make. I'll do the next one. Alright, so this one, start on the y-axis, trace, so we have an up wave, we have a down wave, and then we start to have an up wave again. So that tells you that's one full cycle. Is that sine or cosine? Sine. It has 2 full to begin with. Amplitude, careful, 1.5. The tick marks are kind of funny on this one, but the 4th line up is 1, so it's just 2 above that would be 1.5. Period. How long does it take to make one full cycle? 8 pi. You need an up and a down.
Wait, what's the interval number
1. Alright, so here's the thing with oh, go ahead. Oh, okay. Like here's the thing with these, like you have to be very careful about how you label your x-axis. Like if these didn't have labels at all, could you figure out what the period is? No, unless you have the equation that goes with it. Like you have to have that x-axis labeled. I mean, because I could label this 10, and then your period's 10 now. But it's just really critical that you have that x-axis labeled, even if it's just one label. I would like for you to label at least 2 tick marks, but even if it's just one, like you have to give it some sort of scale. So let's graph some. So for today, I'm going to have you graph the parent function and the one that's transformed, just to get used to graphing the parent function. So for this one, it's sine. So we're going to graph the parent sine first. So I'm going to graph the parent function in red. So I'm going to label the second tick mark pi and the 4th tick mark 2 pi. I'll teach you over the next couple of days how to know how to label that. Just trust me for now. Okay, so when you graph sine, like I always find it helpful to kind of like until you get really good with these, like draw a little baby sine graph somewhere so you know that that's the graph you're trying to recreate. So when you graph sine, I always graph the 0, point first, and I graph the end of the period. So the end of the period for the parent function is just 2 pi. So that's these 2 points here and here. Then the sine graph's going to cross again the x-axis in the middle. So I'd put that point next. And then it goes high and then low. So up 1, down 1. Now again, I'm just graphing the parent function. I'm ignoring that this says 5 sine x. I'm ignoring the 5 for now. Yeah. So this is the parent. And I'm going to do it all the way across, just for fun. I really like drawing the waves, so I'm going to do them all the way across. Okay, so again, this is the parent. Once you get that first cycle set, then fill in the rest of it. Don't try to do it all at the same time. That's crazy. Do the 5 dots, and then once you get those 5 dots set, fill in the rest. Oops, I messed up this one. This one's here. So, woohoo! I'll use a different color. Deja vu, right? Yeah. So, try to figure out the amplitude of the period for that the 5 sine x. So when you look at this, what's the amplitude of the new graph? 5. Period. 2 pi. It doesn't change because there's no number in front of x. So when you look at this, like the horizontal spacing of it's not going to change at all, but each wave, instead of going up to 1, is going to go up to 5. So 1, and it'll go down to 5 too. So, woohoo! Now, I would say the larger the amplitude, the harder it is to make these graphs look wavy. So, this one, when you graph it, depending on how good your artistic abilities are, might look kind of spiky, but I'm sure you'll try your best. Now, you don't always have to fill up the entire graph. Like, 2 cycles is fine. So, 1 to get you started, and if you do 1 more, I'll be happy with it. But if you get obsessed with drawing the waves, like I do, woo, oh, that was a bad one. I was good until about here, and then I got good again. Yep. Yes.
We're gonna go outside.
I think a lot of waves are periodic in nature. I don't know that they follow this like perfect patterns. Like I think there's some like sine waves a lot of times like kind of like do that and then they like get big again. So like there's different like because there's like sine squared and there's like 1 over sine. Like there's all the like we're just yep. Period can't be negative. Nope. Alright, so it depends on how you have it labeled. We might just need to change your label. Alright, so let's take a look at the next one. We're just going to do 1 more today. You're only allowed to pick 1 sine wave and 0 as long as yeah. Alright, so So if you look at the next one, I'm going to graph the parent cosine first. So parent cosine x. So again, all right. So the parent cosine wave. This is the jump rope. So the one that looks like this. All right. So it's gonna start and stop at the high end. So I'm having it start and stop at 1, halfway in between. So at pi, be down at -1, and then it's gonna cross the x-axis in between there. So it kind of looks like a V, or the jump rope to begin with. And I'm going to fill in some more. It is. Alright, so when you look at this, the amplitude of your new graph is going to have to be 3. So they definitely have to get taller. The period's going to be pi. So this is the most important one to get set first. So here's the thing. Right now you're going from 0 to 2 pi to give you one full cosine. If we're only going to allow to go from 0 to pi, that means we're going to start and stop, and we can fit a whole cosine wave in between here and here. So halfway, it'll be at the flow point, and then halfway in between there. So basically, I'm horizontally compressing this to make it fit between 0 and pi. So you're not going to like it, but there's some points that aren't going to hit on a tick mark. They're going to have to in between. Yeah. Wait, so okay, so hold on. So I haven't accounted for the vertical stretch yet. I should have mentioned that.
So like those points don't need to be on there?
No. Okay. So these points, the only thing they're going to move though are going to be the height of them. So instead of being up 1, it's going to go up to 3, down to 3. So it kind of has some extra dots between there we don't need. Yeah. Today's going to be the only day that I have you graph the parent function at the same time, because it does get kind of messy, especially because like there are going to be certain cases where the period of your graph is like 8 with no pi in it. Trying to like graph the parent function, which is in terms of pi, and then the new one, which doesn't have a pi in it, is kind of sketchy, I guess. So today will be the last day I have to graph like this. But if you can see, you fit 2 full cosine waves in between 0 and 2 pi. I'm not going to fill that up because that would be really obnoxious. But you can if you like.
Oh no.